Hi, everyone. I have a question. How many people were in MSR or you can do online too, raise your hand, when Rick was here? Oh, oh my gosh, so many people. Well, Rick is here, so I guess it could be everyone. We had this thing. Hi, Dan Marshall. When you turn your camera on, you fill the entire screen. Yeah, okay. You were right. Yeah, maybe we shouldn't do that. Oh, sorry. Okay. I just liked all the pictures of everybody online behind, but then if anybody turns their camera on, then you could take over the presentation. Okay. Well, anyway, please join me in welcoming Rick Rashid. He's gonna talk about anything he wants, mostly, what he's learned over his career, thoughts for us in MSR. I recently returned to my Microsoft home, and it's been so awesome to be here. And the first person that I thought that would be great to hear from is Rick. So, in real life, it doesn't filter out the lawnmowers playing in the background. So I just hand it over to Rick, and then we'll have some time for questions. You can drop them in the chat too if you want, and off we go.
All right, thanks, Lily. I appreciate it. It's fun being back in Building 99 because for those of you who were around when we originally moved over here, one of the cool things about this building is we actually had an opportunity as an organization to be involved in its design. And so that's why we have these nice lecture rooms and we have the big atrium. There's a whole bunch of things that we kind of specified that we needed to have when this building was originally built. The one thing we didn't really get much control over was the size of the offices. Those back in those days were kind of regulated by the state, which is to say, some entity higher up in Microsoft, but in the building group. But this building worked really well for us, and obviously it's still here, and we're still using it. So there you go. I'm going to talk about a bunch of things, but one of the things I was going to start off by saying is that I don't know how many of you, have had what you would characterize as a eureka moment, right, where you can remember, a particular time and place when you had a set of ideas that changed the course of your career. But for me, the standout eureka moment was about almost exactly 50 years ago. I think we were like in April, not January. But I was in the student union building. It was called Wilson Commons at the University of Rochester. I was a graduate student there. And, I was trying to build an operating system for a mini computer that we had that was going to be kind of our gateway to the internet. We had 4 Xerox Altos that we'd gotten from Xerox. We had, this Data General Eclipse mini computer. And so we're trying to build the operating system for that. And the guy who started the department and who brought me in originally was Jerry Feldman. And he was really enamored with the idea of doing message passing, as the basis for the operating system. He had read the papers by Per Brink Hansen on the RC4000 system, which was an early message passing system, and that was influential in his mind. But I was trying to figure out sort of how to design this system in such a way that the underlying message passing system, in some sense, made sense. Meaning there was a set of abstractions that actually, made sense together and then integrated well with the network, and there was something that we could use to talk with the Altos as well. And so I was just sitting there looking out they have beautiful windows, looking out the window after I'd had my lunch, and suddenly it sort of all started coming to me, how how I would structure things, how I put the little pieces together. And it was like this eureka moment. I mean, I just, even right then, I felt like, wow, yeah, I think I understand what I should do. And, obviously it was a ton of work, a lot of code writing. But we built that system, and then those ideas, elaborated on and refined and so forth, became the basis for what was the accent operating system I did at Carnegie Mellon for the SPICE project there. And then that became the basis for the work I did on Mach, which is the system I'm the most famous for. There's an amusing story about the Rochester thing, though, in that when I was writing the paper for this RIG operating system, we wrote the paper, sent it to a conference. I thought it was a pretty decent paper. I talked about system design and all the components and so forth. The conference I sent it to, got rejected. I was thinking, and I read the comments. The comments make, how you get papers rejected and the comments make no sense at all. It's like, did they read my paper? Or was it someone else's paper? So I had this, again, I had another brilliant idea. I named the operating system kernel for RIG. I gave it its own name. I called it Aleph. It comes from a story by Borges, where the Aleph is this place from which all other places could be seen, right? And I had this great Borges quote at the beginning of the paper. I didn't really change anything else about the paper, just the name of the system and the literary quote. And obviously, it was clear that I had invested enormous amounts of scholarship in this work now. And not only was the paper accepted by a much better conference, but it was the best paper. I mean, it got the best paper award. So I decided after that to always tell my graduate students, if they're having a problem getting a paper accepted, find a really good literary quote, right, that you can use in your paper, and everything will be much better. I think a few of them actually did that. So, but what was interesting is that when I went to Carnegie Mellon, we started building the accent system, and then eventually Mach. One aspect of this work was that I wasn't just building a system for our use. I was really trying to build something that was going to have a broader impact, and in particular, we did the accent system for the SPICE project, and it was great. It got good reviews in its papers. Everything was fine for that. But because it was built on a sort of a relatively obscure, microprocessor-based mini computer, there wasn't any opportunity to really distribute it, right? To have it have a broader impact. So when we started to work on the Mach project, the goal there was what can we do to take these ideas, expand upon them? Because now I wanted to be able to deal with multiprocessors of different kinds, different memory architectures, and so forth. So we were going to be expanding pretty significantly on the system, but also how do we make sure that we have the broadest possible impact for the work? And one of the things that we decided to do was to build, we had the operating system kernel, but to build a Unix layer on top of that. Because Unix was being widely used, we figured, okay, we'll just be a different version of Unix, right? That we'll get these ideas out there. We'll have the sort of principled underneath component of the system, but we'd also have the opportunity for lots of applications to be built on top of us. And we also started to think about, other systems. So, we built a Windows layer. We built a Macintosh layer, right? So that you could run a wide variety of different kinds of applications on top of that system space. And that proved to be really attractive and exciting for a lot of people. The other thing we did is to abstract the hardware layer into hardware abstraction layer, a HAL, and include in the HAL not just sort of the traditional things, like I/O devices and whatnot, but also the memory architecture at the lowest level could be encapsulated in that HAL, and then the operating system built around that. So it was very easy for us to port the system to lots of different machines. And in addition, it gave us the opportunity to not just be porting to a lot of different machines, but a lot of really diverse architectures, right? So many different, multiprocessors with shared memory, multiprocessors with partially shared memories, fully networked multiprocessors. So it gave us that level of whatever you want to call it, flexibility. It also meant that we could port to new instruction architectures very easily, which meant we were the first 64-bit version of Unix, right? Because it was like, a relatively simple job for us to do that, but it was really hard for other people to do it. And as a result, we got a tremendous amount of interest and acceptance into what we were doing. Mach became the basis for the Open Software Foundation's OSF1. It became Digital Unix. It became HP Unix and Compact 264 Unix. And it was like the same code. They didn't really change that much as they moved from one system to the other. But we also thought about other things. So we built, kernel debugger, built right into the system, so you could debug the system very easily. We built programming language tools, so you could take different programming languages and interface them with the messaging system, something we call Matchmaker. We built a software versioning system, right? So we could manage, multi-branching, source code trees as we manipulated and changed the system, and as other people wanted to do the same thing. But we also built our own software distribution system. Both one that would work with the internet, but also one would work with just tape, because a lot of our distribution in those days was just sending out big reels of tape. And the reason I'm mentioning this is it wasn't just the case that we were trying to, build a system, right? What we were trying to do is create an environment that made it extremely easy and attractive for people to use that system that weren't at Carnegie Mellon, right? And as a result, we got distributed really all over the world. There's a legal component. Good news was Carnegie Mellon didn't have any lawyers. They would hire lawyers when they needed it. And so I was able to write the license agreement, and no one could say that there was anything wrong with it, right? And again, the license agreement was part of the distribution strategy, right? Because it made it super easy and valuable for other people to take our stuff and use it and take advantage of it. And I think there's some great stories about this, I guess, too. I should probably say there was a point at which Steve Jobs and an entourage showed up at Carnegie Mellon, really unannounced, because they wanted to look at our operating system and talk with us about it, and I had no idea that they were going to show up, and they came into my office, and so it was Steve Jobs, Bud Tribble, there was some marketing guy, some other people. They were all like in suits. I was in cutoff jeans, slight. I think I had some rips in my shirt. It was summer. It was hot, right? We didn't have air conditioning because we were poor. And so these people show up. I mean, Steve Jobs and those people show up, and I felt a little underdressed. But I decided I would just go with it, right? So rather than just sitting at my desk and having them sit around me, I got on top of my desk and sat in kind of a lotus position, right? So now I was physically above them. Okay. And I clearly looked more, in some sense, it made me look more, intellectual, artistic or something. I don't know what. But it was great. It was a great conversation. Most of the conversation was with Bud Tribble because he was their systems guy. And the reason they were interested in Mach was because they wanted to build their next operating system for the next machine on Objective-C. And it turned out that Objective-C, its abstractions fit beautifully with the Mach message passing abstractions. So it all kind of dovetailed together in this really, really nice way. And, so there you have it. That was an interesting experience. Jobs tried on more than one occasion, tried to either get me to work for them or to consult, and I refused to do both. I never consulted with anyone about Mach because I wanted to be an honest broker, working with all the different people that we work with, whether it was Intel, DEC, OSF, it didn't really matter to me, and so I think he was always a little ticked about that. But they did hire one of my graduate students, Avi Tavanian, who's the lead graduate student of the project, and then he became, headed up the software development for the next machine, and then eventually went back with Steve to Apple, and that's how Mach became the basis for iOS and macOS, is because he took that code and that just became their system at the lowest level. And so even today, as a result of all that, if you're using any Apple product, you're literally using code I wrote, and code I wrote 40 years ago, and if you'd asked me back then, did I know that someday my code was going to be running on a cell phone? I would have said, what's a cell phone? Right? They didn't have, technically there were cell phones back then, but I didn't know about it. So, so it's interesting that, something that you do that long ago can have that kind of a lasting impact. And certainly many versions of Unix, even still today, have my code in it. It obviously had an influence on Microsoft. And Nathan Myhrvold, in his advanced technology group, this gets to the Microsoft part of it, they were actually using Mach experimentally to try to understand, how the system worked. They liked this idea of having a sort of a principled system, a lower level system, and then building what they wanted, of course, is to build Windows on top of it. Eventually, Dave Cutler and his team came in, and built, used VMS-like base, to do some of the same things. But interesting, even in the very early marketing materials for Windows NT, they would use some of the terminology that we used from Mach in terms of operating system personalities and so forth. So it did have an influence into the Windows world as well. Probably the biggest influence as far as this group is concerned, though, is that it meant that they were very, very familiar with my work. And when Nathan and Bill decided that they wanted to start a basic research group, they were looking for someone to do that. And they talked with Gordon Bell. Gordon was helping Nathan with his search. And Gordon knew me really well. And of course, Nathan knew my work. And so that's how I got contacted to come here and start Microsoft Research. Of course, the amusing part of it is that it all goes back to, I was having dinner with my family, in Pittsburgh, and you get this phone call during dinner. Now, phone calls during dinner, usually some kind of a marketing thing, right? Someone's trying to sell you something. In fact, something was actually trying to sell me something. But it was Gordon Bell trying to sell me something. So, I knew Gordon. I said, okay, my wife at the time, I said, yeah, sorry, I've got to take this call, So I listened to Gordon, and I told him I wasn't particularly interested in leaving Carnegie Mellon, but he convinced me to let him and Nathan come and visit me. I figured there was no harm in that. And they did. And they still didn't convince me. But they convinced me to come to Microsoft to interview, or at least to talk to people. I wasn't really interviewing because I didn't really want the job. And the interesting part of that was I came here, and the honest truth was I dealt with a lot of companies at that point, right? All of these companies that were working with Ma. And honestly, I wasn't, generally speaking, very impressed with the people in the companies I was dealing with. I mean, maybe it was just I was dealing with the wrong layer or something, but they just didn't seem like they were incredibly bright. I won't say which companies, but you can ask me later. I came here, and of course Nathan was incredibly intelligent. Loved talking with Nathan, but I met with people like Jim Alchin, Paul Moritz. I mean, a bunch of key executives, and they were all really, really, really smart. Not only that, they actually had read my papers and knew my work, which honestly, most other companies, they were just into the fact that I'd done something. They figured their lower level engineers would worry about the details. And then I met with Bill, and I spent a long time talking with Bill. And I was expecting that conversation to go poorly because I figured, okay, he obviously had a very different idea, I assumed, of what a research group would be than I did, right? He was probably thinking more like advanced development, work with product teams, get some smart people, do some stuff for the product teams. And the answer was no. Pretty much, as we had this conversation, it was clear that he had really pretty much the same set of ideas about research that I did and how to run an research organization. It's not like Bill's a great manager type, but he had a vision of intellectually what the organization might be like. And I was very impressed with that. And I went back to Pittsburgh, and Nathan said, well, what do you think? And I said, no. Okay. Sorry, I still want to stay at CMU. Now, in helping out Nathan's cause was the fact that Carnegie Mellon was going through a transition of leadership, and they wanted to create this School of Computer Science, and they wanted me to run it. Which made some sense because I was running by far the largest group. About 25% of all of the department's budget was coming through me. So that made a certain amount of sense. But from my perspective, that wasn't really a job I was super excited about. It was clearly something that needed to be done, and I'd probably, if I was going to stay there, I would be the one to have to do it. But it really was kind of one of these situations where it's like, well, I could stay at CMU, but I'd be doing that because I'm loyal to the organization, and I feel bad if I leave, right? So that was the guilt thing. And I could go to Microsoft, and I could start this basic research group and build it up from scratch, and have great support within the company. And it's like, that sounds like a lot of fun. And I was going, guilt, fun. Okay. And there are guilt-driven personalities, right? I'm not one of them. If you know me, I'm a fun personality, right? I enjoy doing things that are fun. And I said, okay, and this looks like it's fun. I'm going to do this. Now, all of my colleagues, to a man or a woman, told me this was really a stupid idea, right? How can you start a research lab in the Pacific Northwest, which was, for most people in the computer science community, it might as well have been Siberia, okay? No good researcher will go there. You won't be able to hire anybody, right? And even if you do, Microsoft's this really tiny company, and it's going to go bankrupt. And because only hardware companies were going to survive. There was a guy, really good friend of mine, I taught with him. It was MIT. Dave Gifford. I think he's still at MIT. He might have retired by now. And I at one point I was trying to recruit him to come with me to Microsoft, and he basically said, "This isn't going to work. I mean, only hardware companies are going to survive. Microsoft's too small. Software companies don't go anywhere, and Pacific Northwest, bad idea. All right. If you were doing this, you should do it in Cambridge, right? Or you should do it in Silicon Valley, or even Southern California. But just don't do it, or even Texas, for God's sake. At UT Austin, just don't do it at the Pacific Northwest, because that was such a stupid idea. And so we actually made a bet. It was only 25 cents. I don't really bet a lot. I have a history of making 25-cent bets with people I work with. And the bet was whether Microsoft or digital equipment was going to be around in 10 years after that. Well, you know how that went. So for a long time, I had this check for 25 cents, on the board in my office, but it eventually got so faded you couldn't see it anymore. So, but one of the things that I think was really important, so coming from what I had been doing at Carnegie Mellon and coming to Microsoft, there were sort of two things. One was I really wanted to take that ethic, that sort of the ethos of CMU, and bring it with me, right? They had this notion of a reasonable person principle, right? Where as long as people were doing reasonable things, that was fine, right? I mean, you don't create a set of complicated rules, that try to govern people's behavior. You assume they're reasonable and that they're going to do reasonable things. And then you deal with the exceptions if there are any, right? If people do unreasonable things, you could just solve that problem. But don't try to create a structure that's not going to allow that to happen. Instead, just assume people are intelligent adults, they're smart, and they're going to get things done. The other thing that I, of course, brought with me from that is this notion of what's really the goal of research. And the ultimate goal of research is pushing forward that state of the art, making it so that we're just changing what we're capable of doing, as scientists and as engineers. And so that became kind of the first part of the mission statement for Microsoft Research was our number one goal, overwhelmingly, is we're here to push the state of the art forward. Doesn't really matter how or when or what it's about. If we can make progress against the knowledge that mankind has and the engineering that mankind is capable of doing, that's what we're trying to do. And that has nothing to do with Microsoft, has nothing to do with anything else. It's just about science. I mean, the second part, though, and this gets back to what I'd learned with the mock project, was when you have really great ideas, work your butt off to try to make sure that they get used, right? And that you have an influence with your work. I clearly had taken that approach, because we could have just written some papers about mock and that would have been it, right? But no, we built an infrastructure that made it really easy for other organizations to adapt it. And as a result, there's still this lasting impact 40 some odd years later, right? So that was the other part of what I was hoping that we'd be able to do as an organization. I mean, ultimately, it gets back to, if you're familiar with the paper by Vannevar Bush that helped to start the National Science Foundation, it gets back to this notion of what are you doing when you're doing basic research? And the answer is in some sense, you're creating an insurance policy for mankind, or for the United States, or for Microsoft, right? You're building a treasure chest of ideas and technologies and people, more importantly than anything else, that when the shit hits the fan, you can rely on to help solve that problem. So his perspective was, there's another war. You want the technology to win that war. I mean, a lot of technology helped to win World War II, and he took that and he said, other wars are going to come. We're going to want that technology. But also, what if there's a famine? What if there's a pandemic, right? When the COVID pandemic occurred, one of the things that allowed us, as a society, to have vaccines fairly quickly against COVID was all the basic research investment that had been made in the mRNA, space, and the fact that companies like Moderna and others and university labs had pushed the state of the art to the point that they could rapidly deploy, a vaccine. And there's some controversy about that in some quarters, but it made a huge difference. And I think that's kind of the other part of it. It's like being prepared to solve problems you don't know you're going to have, right? Or you actively believe you won't have. And yet, if we keep pushing the state of the art forward, we're going to have ideas and technologies that if the time comes and something happens that no one was really expecting, then you can suddenly be able to deal with that. So a good example of that is some work that was actually originally started by Nathan Myhrvold. Gideon Yuval was kind of the intellectual person that drove a lot of the actual intellectual part, and there was a number of people, Bob Davidson and others, that helped to do the implementation. But early on, going back to 1992, really early in Microsoft research, we started working on, basically working set size optimization for systems. And the idea, this is the thing that became, we originally called it Lego, but then the Lego company tried to sue me. So, then we called it BBT. But the idea there was, could we monitor the behavior of 32-bit, code as it executed, and then break that code apart at the basic block level, rearrange the basic blocks, fix up all the jumps, and do that in such a way that the part of the code that mostly executed, was fairly compact, which meant that your working set size could be dramatically reduced. And in our original, I got put in charge of this project. In the original part of this, we discovered that we got about a factor of 2 improvement in working set size. But not only that, we dramatically improved caching behavior. And so the code ran a lot faster too, right? So that was a side benefit that wasn't really part of the original idea. We were really excited about these results. And so we went to the Windows team at the time, and they were still doing the 16-bit Windows, right? So we did a big presentation to them, and lots of math to describe what we were doing and how it was working. And the end of that meeting, I thought the meeting went pretty well, but the end of the meeting was, them telling us, you guys are really, really smart. I mean, I know you're smart because I don't even understand what those symbols are, that you're using. So you're just really smart people. And I'm sure, if you work hard enough, you'll eventually come up with something we can use. All right? But we don't have 32-bit code, right? And this is all for 32-bit code. We only have 16-bit code. And we're going to have 32-bit code someday. So we know they were already moving toward that. But they said, look, by then, memory sizes were going to be a lot bigger, right? It wasn't going to be an issue. We weren't going to have a problem. And so thank you guys for being here. It's nice to have smart people around, and don't bother us too often. Okay? Now, we also met with the Windows NT group at the time. Of course, they did have 32-bit code, right? And that meeting went really well. because those guys really did understand what we were doing. They did understand the math, right? We had super lively conversations. It was great. I thought that was a fantastic meeting, and they were just going to immediately want to use what we were doing. And so I was really very optimistic. And then after the meeting, Dave Cutler came up to me, looked me in the eye. Dave, much bigger guy than I am, much stronger guy than I am, at least at the time. He looked me in the eye, and he said, "You're going to do this to my operating system over my dead body." And I was completely certain that he did not mean his dead body. Okay, we were discussing my dead body because he could easily have snapped me in two if he wanted to, And I know he'd put his hand through walls on more than one occasion. So he was kind of a scary kind of interaction. So the good news is, so they actively, neither one of these groups actively, they didn't want to even hear from us really ever again, right? But we still believed in what we were doing, and we convinced Bill that that this was something we should keep doing and keep putting energy into. We actually even built up the group, and not only did we keep building the system, but much like the work I'd done on Mach before, we did everything that needed to be done so that code could be directly used in the production process by the product teams, right? So we would do the same builds that they were doing with our code. We were running the same tests that they were running with our stuff, right, after it had been transformed. We would do all of our analysis. Basically, we created a sort of almost like a shadow product team, right, to be able to make sure that if at some point they needed the technology, that we would have it available. So the good news here is that, well, good news from our perspective, not really good news for the world, was that, much like today actually, there was a DRAM shortage. Okay, I'm sure you've never heard of a DRAM shortage. So, and it had been created by some, trade issues between the United States and Japan, in Asia more broadly. You've never heard of trade issues either, I'm sure. That it's funny how everything comes back, right? It's just a big cycle of life. And so, as a result, we were getting very close to the point where we needed to ship now our 32-bit Windows 95 and Office 95, but the amount of RAM that was routinely being used in the machines that our business customers had was not really changing. So they were mostly using 4 megabytes. It's important to remember back then it was megabytes. It took us a while to get to gigabytes. And the system was really kind of built around the notion that it would run well in 8, right? Because everything is sort of, both the data and the code were both twice as big, right? And so it really didn't work well with 8. I'm sorry, with 4. And that was a problem because we're about to ship this product. It was going to be one of the biggest products in the history of the company. And it wasn't going to work very well. And so the good news was, hey, research to the rescue. We had our stuff. And not only did we have it, but it was production ready to use. As a result, they were able to ship Windows 95 and Office 95 and have it run well in 4 megabytes of memory and really fantastically in 8, when our competitors really couldn't do it. Remember when Ray Ozzie came and working at Microsoft, one of the things he was talking to me about was the fact that he said he knew when he was at Lotus that we had something, right? Because they couldn't get their stuff to run well in the smaller machines. And our stuff was running. And he didn't know what it was, but he knew we had something, right? And so it gave us not only the ability to ship on schedule, which was hugely valuable, but it also meant that our competitors, Lotus and WordPerfect at the time, who are big competitors in the office space, they couldn't match what we were doing. And they didn't even know what we were doing. It was just, we didn't publish this stuff at the time. And so we won, right? I mean, it was a strategic opportunity for the company and had a huge impact on our growth during that period and our relative position. Because, Office was, Lotus and WordPerfect were serious competitors for Office. And we were able to lap them during that time. I mean, they eventually we were able to catch up, memories got bigger and so forth. But we had that first mover advantage. And so here's an example where the sort of the outside world, product teams in this case, both actively didn't want the technology, right? They didn't think it was valuable. They didn't want it. But when the time came, we had that, treasure chest, right, available, right? We had those ideas, but also we had the artifacts, right, that allowed those teams to rapidly adjust. And, I think that's one of the great values of a basic research organization is that you're more often than not, you're doing things that are significant, far enough out in advance of what the product groups might be doing, or the rest of the world might be doing, that it may not seem valuable to them. I mean, there's some things that are, you're always going to have some things that are directly valuable, right? The things that you're working on that are right in line with what other people are doing. But there's a lot of stuff that won't be. And yet, there may come a time, right, when suddenly it becomes incredibly valuable. I mean, the same thing happened with search. I mean, you won't believe that all the meetings I went into on that. Even my wife, Terry, I mean, she was involved in some of that because she was working in Bill's office at the time on search and trying to get it adopt, the search ideas into the company. And, there was kind of an active, resistance against getting into the search business. And then they realized, based on what Google was doing, is that there was actually money to be made, right? So as long as it was just a technology, nobody really seemed to care very much about it. But as soon as somebody demonstrated you could actually make money, right, then suddenly it became really interesting to the product teams. Moreover, as Google started to quickly build an advantage, it started to look like a threat. And so again, this is an example where we had the product teams, come, to research. The guy was in charge of getting Microsoft into the search space, eventually became Bing. And he came to my office. He basically said, okay, here's my list of my 50 best people. Where's your list of 50 best people? And we can get them to work together in this space. And it wasn't just about search. It was also about building the systems infrastructure, right? Because Microsoft didn't really have the underlying systems architecture to build large-scale data center search. Right? So we had teams from Redmond, but also teams from, at the time, Silicon Valley, working really hard, and also Cambridge, working really hard on this issue. How do we work with? I mean, what are the key ideas? What are the things that we can do together that will allow us to rapidly enter that search space and start to become competitive, with Google. And it took a while for Bing to get profitable, but it is profitable today, or at least it was when I left. So I think this is something where again, a lot of the value of what we do as computer scientists, in a basic research environment, is about something that might happen in the future that you don't know what it's going to be, right? It's about the opportunity to save somebody's ass, when the time comes that they need saving. And, and it's not always going to happen. I mean, there are going to be lots of situations where, where some line of research moves forward, and then things change. The nature of that area of the field changes, but there still may be some ideas there that carry into other things. And so I think it's important, as researchers, that we're always thinking about, how do we just, where do we need to advance the frontier, right? It isn't just about, what can I do that we can use right now? And that's, it's great. I mean, I did a lot of that when, over the years. I mean, I built a lot of stuff, purpose-built to help people do something right now. And that's valuable too, especially when you're trying to work with teams to move technology, into use. But if you're not sort of also moving that state-of-the-art forward as a broad organization, then ultimately the value of basic research isn't super high, because you're going to be superseded by other people, right? You're not really doing the thing that is the most valuable, in the long run. And I think again that was part of the underlying philosophy that I brought with me, when I came to Microsoft Research. And I think over the years, we really did, embody a lot of that in the various projects that we did. One of the things, I know some of you, a number of you know this pretty well. One of the aspects of running a research organization, there are lots of it. Running a large research organization is really complicated. Okay, I think for the most part, people thought I was making it look pretty easy, but there's a lot of underlying detail. One of the things is, if you've got 1,500 people working for you, someone's having a serious problem every day. and ideally you can help them solve that problem. Sometimes you can't, but that certainly weighs on you, right? So I was talking with people last night. It's like when you're in my position, at the top of the organization, and there really was nobody above me, because technically I was reporting to Bill or Steve for a while. I think Bill was like 15 years as Steve, and then and Craig Mundy. But none of those people were. They weren't going to make any decision for me, right? I was the end of the decision chain for my broad organization, and people don't bring decisions to you at that level unless there's no good answer, right? If there's no good, because if there was a good solution, they're all really smart people working for you. They'll have figured that out and have solved it on their own. The reason they're coming to you, frankly, isn't to solve a problem, because they would have solved it. It's to take responsibility for the decision. Because at that point, there's clearly some aspect, whether it's interpersonal, organizational, whatever, financial, whatever. There's something that has made that decision impossible for the people underneath you to resolve. And so your job is basically just absorb it, right? Take make the decision quickly. My goal was always to take about 10 seconds, listen to what everybody said. But again, at that point, it's probably arbitrary what choice you actually make. I mean, sometimes it's not. I mean, sometimes people aren't recognizing the problem properly, and you can really solve it. That's great. That wasn't probably the main thing that would happen, but when it did happen, or it's like some ethical, moral thing, and sometimes people just need someone to say, that's wrong, we can't do that. But most of the time, it's like, just decide. You don't have, the most, at that level of an organization, the most important thing is to make a decision quickly. Because for as long as that decision is not made, there are probably people doing things they shouldn't be doing. often they're hurting each other, right? Or actively working against each other in some fashion. Because they're hoping that their thing will work, that they'll take over and you'll decide for them instead of somebody else. So just make that decision. Get everybody on the same page, solve that problem, and just move on. And it doesn't even matter if it was the right decision or not. Because if it's a wrong decision, you can fix it later. But if you make no decision, that's the worst thing that you can do, right? And I think that's something that again, you learn, when you have a very large organization that, and for things like, I manage large product teams in addition to running research. And, there, a lot of times the world has changed and you have to do a reorg of some kind, right? Product teams are inherently, organizationally unstable because the world keeps changing around them. Their businesses keep changing around them. And it's structurally, a product team has to be focused on delivering something. But when suddenly it changes and then that thing doesn't need to be delivered anymore because there's a new focus, right? That team, it's very hard to take that team that was designed to do one thing and suddenly make them do something different. The easier thing is to break them up, restructure everything, and have new teams focused on the new thing, right? That don't have this legacy, in the old space. That's why you tend to see product teams reorganize a lot. There's the old joke that says, never reorganize without a good reason, but if you haven't reorganized in 18 months, that's a good reason. But partly that gets back to the fact that world changes a lot, right? And the best way to affect change is structural and organizational. And so that's why you do it, right? Research organizations are actually the opposite of that. They actually work best when they don't get reorganized much. And they work best when they tend to have a fairly constant management for a long period of time. And that's because you really do, going back to my earlier point, you really do want people pushing the state of the art, which often means they're working on something for a long time, right? And if they're uncertain whether the success metrics that are going to be used for them and their careers is going to be changing underneath them a lot, then they're not going to be willing to take as much risk, right? So ironically, in order to take risk, you need to be in a more stable environment. And in order to be stable, you need to have a more unsettled and unstructured environment, which is what the product teams are, right? So they're structurally at risk, but they're trying to deliver something that's very stable, right, and that works well. Research is really kind of the opposite of that, because you have to understand that from a management perspective. Like I said, ran both kinds of organizations, very familiar with how both of them work, but it is a key element, of thinking about what you're doing. And one of the things that can happen in a research environment sometimes is that people really completely on their own with no, there's a tendency sometimes, both individually and sometimes in groups, for researchers to become risk averse. They've been working on something for a long time, and they're no longer necessarily thinking about the counterexamples and the counterweights to what they've been, because they've invested some energy for something in a long time. But you need to be able to constantly reevaluate as you do your work whether things have changed intellectually. I mean, that the world, the opportunities have changed, the tools have changed, whatever. That would now mean either that what you were doing isn't necessarily the right thing to be focused on anymore, or whether there's now new opportunities you need to be examining. So again, one of the things in a research organization that I would have to think about is, how do you push people off, their center points from time to time? You don't want to do it a lot, but again, it's important to sort of give people or put people in a situation where they're willing to take on like super hard problems, right? And not and not just get stuck in their narrow areas. And I know, I mean, look, I think if you look at stuff that gets published, there's a lot of rat holes out there, right? There are a lot of rat holes in the research space. So you have to be careful to make sure you're not in a rat hole too. So there's this period leading up right around 2009, 2010. So not that long after the big financial collapse, right? There was a lot of, people were a little depressed. Stock was really low. A bunch of things were going on. And I was feeling like, energy levels had maybe been dropping a little bit. And I needed to give people some impetus. So I came up with this thing, which I think I sent the memo out in 2010, called the Impossible Things Initiative. I know some of you are familiar with that. The goal of that was to basically say, let's think about some things that are really, really hard that we have absolutely no idea how to do. All right? And figure out if especially if we can work across groups, can we somehow make progress in these areas? So one of the key things I mentioned, so I threw out a few ideas. We eventually created a little bit of a process to try to come up with new ones, but the first idea I threw out was this notion of speech-to-speech translation. And I still remember, so I had this notion that I wanted to be able to go to China, give my speech in English, and have it live translated into Chinese. Because I was getting tired of the whole, the whole translator thing. And I sort of pointed out, there's some cheaty things that we could do to help. For one thing, it's not that I have a relatively decent diction. Okay, I come from Iowa, so don't have a terrible accent. I've given 200 million speeches, and so there's just a huge number of transcripts out there. So you almost could guess what I was going to say, even if you didn't actually know what I was going to say. If you did, you'd probably be better off than I am. I don't always know what I'm going to say next. So I put that out there, and I was hoping to get some excitement generated. I still remember, I think it was the next day, I would always go to the lunchroom and have lunch with different groups, not intentionally, meaning we didn't try to schedule anything. I would just see a group sitting and I would go sit with them, right? And I happened to be sitting with the speech group on that day. I can still remember there was this young researcher, whose name I no longer remember, who was just haranguing me. He's basically saying, you clearly don't know anything about this space. Actually, I did know something about the space, but he thought I didn't know anything about this space. He said, we've been making just incremental progress in speech transcription. The translation process is extremely difficult. The chances we're going to be able to make anything other than incremental progress over the next 10 years are very low. Now, normally, it's the young person who is, really gung-ho and saying, I could do anything, right? And it's the old guy who's saying, hey, I've been through this before, it's, whatever. But it was just total role reversal, right? We were not, I kept trying to convince them to say, no, there's some things you can do right away, there's some things longer term and so forth. About a year later, so in particular, the guys in Asia, Microsoft Research Asia got pretty excited about this, but also the local speech group did, and a bunch of people got involved. Machine translation team got involved too. About a year later, they came to me saying, okay, we've built this system, and we think it might be able to do what you want it to do. so they brought the system to my office, and I started talking with it, and it just made a lot of mistakes. And they said, okay, well, it's making a lot of mistakes, but we'll get it fixed by the time we're on stage. And I can still remember being on stage the night before doing rehearsals in China, and it was just not working. It just didn't do anything right. And I said, look, we're just not going to do it. We just don't, optional, we're not going to do it. Thank you guys for working so hard. I know you feel bad about it, but I'm not going to be the Microsoft executive who stands up on stage demonstrating something that says something really bad, right? Translates me into some terrible, culturally inappropriate, set of comments. I'm just not going to be that person. We're just not going to go there. So that was fine. That didn't work, but there was this, there was a lot of work being done, sort of, in that sort of same general time frame, around beginning to use deep neural networks. And some of our guys knew Jeff Hinton and his people really well. Jeff came, and some of these guys came and worked with us to adapt some of the work that had been done in image, area to the speech area. And I think it was a year later. I think it was 2012. Might have been 2013. You can look it up. The speech is still on the internet on YouTube, where they brought their new system, and part of what made it work wasn't just the deep neural network stuff, but they'd also invested a huge amount of energy in using GPUs for training, right? Because the only way you could actually have this stuff progress at any reasonable rate is if you could train at a reasonable rate, right? And the training was the huge bottleneck in the system. So about a year later, they came to my office, and again, I might be slightly off in the time frame, but you can look it up online. They had the system sitting in my office, and it was turned on. I don't know that anybody thought it was turned on at the time. And literally, as we were chatting about it, it was just randomly transcribing everything we said. And it was doing a really good job. I mean, a really good job. And not only had they done this work, but they'd also done work to take the text to speech part and make it sound like it was me talking in Chinese, right? So then I went on stage in Tianjin in front of 4,000 or 5,000 students and faculty, I know Eric Horvitz was in the audience. A bunch of other people were there, and we used this thing. And you can find the YouTube video of me on stage doing it, and it worked, really well. And I still remember, as I looked out at the audience as this was going on, that there were like students crying. They had never thought that this could happen, in their lifetime. Maybe they were like that one speech researcher. It had a profound impact, and obviously, it was an early demonstration. Those technologies might have been getting used within Microsoft products. Other people adopted these ideas and expanded upon them as well, right? But I was probably the first senior executive of a major corporation to be willing to go on stage and use a system like that. And I think that's, again, that's something where sometimes the most important thing is to give people a goal that's like really, really hard. Because a lot of times they'll just figure out, okay, well, yeah, we're supposed to do that. We'll figure it out. I don't know how. We'll keep trying ideas, trying technologies, working with other people, looking at the literature. And this was very much a cross-group collaboration. It was very cross-group collaboration to make this work. I think that's something that, either as individuals or as groups, we constantly need to think about, are we setting our goals high enough, right? Are we trying to do some impossible things? I remember a few years ago, I was having a conversation with the guy at SpaceX that was responsible for developing the landing part, right? And the honest truth was, they were basically told, we're going to, it's your guys' job to figure out how to land the rockets. And there were a lot of people outside that who thought that really wasn't going to happen. And boy, they made a lot of mistakes early on. There were a lot of rapid, unscheduled disassemblies that happened. And I remember him telling me about one of the last ones. So coming up with so originally they thought they could do this with thrusters, and that just wasn't stable. And then they came up with the fin idea of being able to use fins to help stabilize. And that was working, but I remember he was telling me, the last one that didn't work, he was saying he felt really bad because he'd done the calculation of how much hydraulic fluid they needed, right? And it was just not quite right. And so the thing was great, crash. Okay. But they learned from that, and now they landed almost 200 rockets last year, right? So now it's just routine. You just assume the darn thing's going to work. So, but I think again, sometimes it's somebody saying, "I believe this is possible. I want you people to do it." And what that does, it gives people license to do some crazy stuff, right? And it's not always going to work. That's fine. In this case, in the case of the rockets, it did. In case of the original speech-to-speech thing, it did. But even when it doesn't work, a lot of times really good new ideas come out of it, right? And I think that's kind of a message to take home, which is, it doesn't always have to be the case that I accomplish exactly what I started to do, although that's great if you can. But hopefully it's the case that something really good comes out of it. Maybe something unexpected, some new direction, some ideas that you weren't thinking about, some collaboration you weren't expecting to produce a certain set of results, right? And I think that's where there are a lot of opportunities. So I've been talking for a lot of time. I wanted to have a chance to have people ask questions, and so if you have any questions, you can ask them. If you don't, I'll keep telling stories. I could tell stories about lots of things. I can tell running stories. One of my big hobbies right now is doing trail running and trail racing. And so, which I'm 74, I'll be 75 a little later this year. There aren't that many men my age that engage in that particular activity. I run in a lot of fairly large races in the Phoenix area and Utah and stuff. And a lot of the races, probably at least half of them, I'm the oldest person running in the race. They don't give a prize for that, which I really don't understand why they don't. I would love to have a prize for that. It does mean I'm often first in my age group because there's nobody else in the age group. But you see a lot of 70-year-olds and 80-year-olds will run road races, road marathons and stuff. And I ran marathons too. I ran one back in September. But but I think people just get really worried about falling and hurting themselves, especially as you get older. I totally understand that. But as you've probably gathered from the conversation, I'm an incredibly optimistic person. And my assumption is, sure, I might fall, but I'm not going to really hurt myself too badly. So far, that's proven to be true, right? So it all worked out. But I think, again, that level, you have to have a level of optimism to be willing to accomplish things. And in my case, the level of optimism was is that, yeah, sure, I'll fall, but I won't hurt myself too badly. I did mangle my finger a little bit. And that's not going to go back. But that was a couple of years ago. But it's fine. Yeah, well, I'll figure it out. I'll make it work. And I think that's kind of the philosophy I've always carried with me. I know a number of you know that back in 2019, I was really sick with a very acute leukemia and nearly died a couple of different times. And Lily visited my hospital room, and I looked like shit. But someone was asking me the other day, it's like, has your attitude about life changed since you had these brushes with death and you were so sick and everything? And I said, no, not really. I mean, I just assumed I was going to survive, right? It was just a question of hanging on long enough for the find a treatment, and I did. And they, about a month before I was just about to completely kick it off, they found a treatment. So, hey, I accomplished my goal. Yeah, stay around long enough. And it's funny. I would always joke with people, I want to make sure that they're self-driving cars before I can't drive myself, because it was very traumatic, for some of the older people in my life, when they could no longer drive. Right, you had to take their keys away, and but I have a Tesla. It drives itself. I rented a Tesla here. It drove me here. I didn't do anything. My hands were in my lap. It parked itself. Everything was great, right? And so we're pretty close to the point where if I can't drive, my car will just do it for me, right? And I think that's where there's an opportunity. If you think about the things we can do within research, there's an opportunity to really change people's lives in a really substantial way. And I think that technologies like rockets that land on their tails, so that and are reusable, so that you can create satellite networks, quickly and efficiently. The self-driving cars, the speech-to-speech translation, which now is completely routine. Those are technologies that change people's lives. And we can continue to do that. And that's really why I got into doing research in the first place. Is I wanted to change people's lives, and heck, I actually did. Lots and lots of hundreds of millions of people, maybe more than 1 billion at this point, are literally using my code every day. That changed people's lives. Anyway, questions? Yeah.
Thank you, Rick. It's really interesting to hear the stories and remember some of the times with the impossible things, for example. I was on one of those projects. So I wanted to ask you a question. So we see how AI is changing how we do science, how we do research, et cetera. And also it's affecting the whole process of sharing results, sharing papers, et cetera. So I'm curious what you think about the impact, if it has any, on the research process. On a research organization like Microsoft Research, would you, now that we're in a different world, would you change how you do things, or do you think many of the principles that you discuss are still highly relevant?
Well, I think the principles are completely relevant, but at the same time, I think like the AI tools we have now, I think offer opportunities for researchers that are just tremendous, right? It used to be, if you had a researcher in an area, and they needed to think about they needed code written, or they needed to do that, we'd have to hire somebody to do it for them, right? And we actually created a group specifically because I didn't want to hire people for every group, right? So we created a group that we could sort of farm out, resources, to get things done for the various research groups. Now, in a lot of cases, even people who really don't know how to code can create code with these new tools to test something, or to get something done, or to work out a particular idea. And so that really does that leverage. It's like, like in the old days, professors at university, everybody had their own secretaries. And they were really called secretaries back then. At a certain point, nobody had a secretary, because you don't need them, because it was just all on the computer, right? So I think there's an opportunity for those tools to do that. I think the other part of it is that there's huge opportunities to think about, are there ways to frame certain kinds of problems that fit some of these new technologies and tools, right? We've seen that before, even just in mathematics, right? Math tools developed in one area for things like principal component analysis and whatnot, suddenly get used in vision or in medical analysis or things of that sort. So this is no different, right? These are tools, these are ideas. And so there's an opportunity, I think, to think about how do we sort of, are there ways to leverage what's already been done, but in completely new ways that other people haven't thought about, right? And I think that's something that changes too. Like even in my career, building systems, one of the problems I would see with other researchers in the systems area is they were often not keeping up with the changes in hardware and the changes in architecture, and so they didn't realize that old ideas that in some sense were really shitty, terrible ideas had suddenly become good ideas, right? Because suddenly the hardware could do things that you couldn't have done before. So I remember just in my work, we did about one of the key elements of Mach was you being able to use copy and write, right? But there was this philosophy that in those days that said, copy on write is never going to work. I mean, in fact, the first Mach paper I gave at a conference in 1986 was in Phoenix area, amusingly enough. Literally the talk right before mine was a talk where the person, intended to prove that copy and write was not a viable mechanism for operating systems. And I love it when you just get set up like that, because then I could come on stage and not only say that it works, but I had code and demos and we were willing to distribute the software to anybody who wanted it. I just got mobbed in the elevator, after that talk, because everybody was like, wow, this is cool. How do I get it, right? So sometimes having that foil, is great. Someone who says something can't be done. This actually happened in a computer. My PhD thesis was in computer vision, and the same thing happened there. My talk came after somebody else who basically said you couldn't do something, and I completely demonstrated that way you could do it. I already did it, and I had all these examples, and I was able to show them on stage. But I think again, you just have to keep paying attention. It's really hard. As your career moves forward, it's very hard sometimes to be willing to, not have so much of a memory of everything that didn't work before, that you're not willing to try it again if circumstances change, right? And it's like the NFL quarterbacks, the ones that succeed the most are the ones that just forget that they threw an interception, right? And they just throw the damn ball again, because if you spend too much time worrying about something that didn't work before, then you don't try something new. You don't try the next thing. So I think that's the part of it too. And I think there's an opportunity. For me, I don't do research anymore, but I think that the opportunity to leverage these new ideas and new tools, it just seems like there's just so much open space there, and being able to take advantage of that seems like a no-brainer. And it's not like there's a lot of stuff is just widely available. I mean, even the open source models and so forth now, they're widely available to be used. I mean, you don't even have to rely on some product team to give you something. You can just go out and use open source, right? Because it's available, and that's what a lot of universities are using. So there's again, if it were me, I'd be trying to rethink everything I was doing with these new tools, and then also be thinking about, well, yeah, but what happens after that, right? Because clearly there are limitations in what we're currently doing. And so how do I think about that? And are there different ideas or different approaches that maybe, I should be looking at as well? Yeah, another question.
So can people online hear me? I don't know who's
There's a mic.
If you yell loud enough.
Yeah. All right, thanks. Thanks, Anna.
I figured they could hear you, Ben.
So Rick, when I look around, Microsoft Research has been here 35 years. We still have these values that you espoused, fundamental open research, drive to, change the industry, change the world, do really hard things. And as I look across the industry, obviously Microsoft needs to be healthy. I don't even know if this is on. It wasn't on, that's embarrassing. Obviously, Microsoft needs to be healthy for us to be healthy. Okay, that's table stakes. But all these other companies seem to have tried research labs, and yeah, they have research, but they, I don't know how many names I should name, but like Meta had FAIR and kind of ramped up and then ramped down, and Google's had research in DeepMind, but research, everyone got a buyout offer. They still have DeepMind, but their mission is shifting. Why do you think the organization that you founded has been so durable with those values when most of the others have either come up and stopped or they were extant like IBM Research and kind of just petered out? Like, why are we so stable?
I think some of that is management, upper level management, right? So if you think about, I think, Satya is actually someone I worked with in the old days, right? I mean, he both leveraged work out of research himself directly, but he also worked, in his very early days, he worked with me, on some of the interactive TV work that we were doing, right? So he's had a long history working with us in different ways. Clearly Bill believed in it a lot, Steve understood the value because he saw the results coming back. Steve also thought we had he was also very interested in how I managed the organization. I remember the first time I met with Steve when he technically became my manager. It was always really Bill, but there was a point where Bill was the, quote, chief software architect and wasn't supposed to have reports. So I had to report to Steve. And I went to Steve for like a review thing, and my conversations with Bill were always technical.
Yeah.
They were never personal, right? But the first thing that Steve asked was, you have all these really, really smart people. How do you keep them from hurting each other? Just a little complicated answer, but
You bring in Dave Cutler.
Yeah. Right. Well, but there are a lot of spaces where, honestly, if you have, certainly in some groups, if you have too many smart people, they will hurt each other.
Yeah.
Right? Because there are too many alphas, and it just, research. I think we've developed a culture where you could still be alpha, but you were being alpha versus everybody on the outside. Okay.
Yeah.
You didn't have to hurt people locally because that didn't get you any plus points with me, right? I mean, the value system we built up internally was such that you were in some sense disadvantaged from trying to hurt other people, whereas if you wanted to hurt some other research lab, go for it, okay? We were all about winning.
Yeah.
I mean, the first thing I did when I came to research was figure out, okay, let's analyze our competition. And we did that. And we spent a lot of time going over, the different labs, different organizations, their hiring practices, kind of people that they were getting, how much money they were spending on them and so forth. Because my goal was, I'm going to beat these guys. So I need to understand what they're doing.
Yep.
So that I understand both, are those things we should do, but also what are their disadvantages? What are the things that make them vulnerable so that we can attack that, right? So I'm happy to beat the other research organizations, but internally we don't really want people hurting each other. I mean, ideally, that doesn't say that it never happened, but I think it. But I think again, there's such a long history of research working with the company, working with the product groups, rolling up its sleeves when it had to.
Yep.
I mean, there were a number of instances I didn't really talk about. Number of cases where the product group had a serious problem. And they came to us, and we treated it seriously.
Yep.
There was at one point we were being sued by this is for DOS 6, 1992. We were being sued by a company called Stack. They bought some patent from. They were in the space of doing memory and discompression, and DOS 6 was going to have those capabilities, and they prevented us from shipping that, and so they bought a patent from somebody in England, and they used it to sue us. And so the product team came. Honestly, it was like 6:30 at night over in Building 9. We maybe had 20 people working in research at the time, and they said, we need a new compression algorithm now. And there was a guy, a very young researcher, really good at the time, John Miller was working, that he and I, because I'd had experience in the compression space too, he and I basically just sat together, and for roughly 6 months, we invented a new compression algorithm every day, right? And every day it would be reviewed by the lawyers, and every day it would be implemented by Ben Slivka and his DOS team, Jeff Parsons, Mark Zubikowski and those guys. And then every day we'd circle back, and the lawyer would be uncomfortable with what we were doing, or there'd be some problem with the implementation, because you didn't have to just invent a new compression algorithm. It had to be a compression algorithm that took no more than a certain number of instructions, right, and could be executed in a streaming fashion inside an operating system kernel. The very specific set of constraints. So we did that for a while. We came up with something everybody was comfortable with and liked. It was called double space, I think. Shipped with DOS 6, but then the lawsuit kept going on, right? And then at a certain point, the lawyers they were always hoping to get it dismissed, but at a certain point, the lawyers came back and said, no, this is going to go to trial. And none of the jury have most of them didn't have college degrees. Almost nobody knew what they were talking about. So they said the result of this jury trial is going to be completely random. Yeah. And so it was in Southern California, which is where Stock was located. So that's not necessarily a good thing either. And so, John and I rolled up our sleeves again. We just did the whole thing again. Came up with another algorithm, called drive space, I think. And so we shipped that. And the idea was to ship with the new algorithm before the case was decided. The case was decided, it was decided against us, but because of all the work that we'd done, and I spent 3 days being deposed about this, they felt that we were not willfully infringing. So they didn't get treble damages, they only got the main damages. And I think it was like $40 million. It was still real money back then. But they could not enjoin us, right, because we were always shipping something else. So they'd have to go through the whole process again, and they didn't have the money to do that. Yeah. Right? And so we settled with them, and part of the settlement was buying some of their stock and doing some other things, right, which ultimately we were able to sell their profit. So actually it was like a net zero. So effectively, Microsoft Research, not only did we save the DOS product, right, but we made the company like $80 million, okay? But we also, this is 1992, really early days, right? But we also proved to the product teams that these research guys, they're serious, right? They'll roll up their sleeves, they'll work as hard as we do, right? Which impressed them, because they didn't think that was really going to be the case. And I think that the legacy of things like that, still live in some mental space within the organization. The fact that, there have been times when we made a big difference, right? But we didn't pretend that we were different than them or anything like that. We basically said, great, we'll figure this out. Roll up our sleeves. What do you need, right? And that builds trust. Yep. And I think the biggest thing that a lot of these other organizations lack is trust.
Yes.
and the most important, when you think about technology transfer of any kind, trust is like the top part of the list. Do the people trust each other? Do the researchers trust the product team? Does the product team trust the researchers? Do people feel like that they're actually working together? Whenever we would have somebody working with the product team that looked like they were trying to take too much credit, I would come down on them and say, look, you get credit lots of other ways. First off, I give you credit, your papers give you credit, the outside world gives you credit. You don't need to take the product group's credit.
That's right.
Right? They deserve that credit. That's how they get their bonuses. That's how they get their promotions. Right? So your job is not to thump your chest and say, I had an idea and it was important to these people. It's to be, to help them have better lives and better careers.
Right.
Right? And if you can do that for people and they recognize that you're helping them, have a better life or a better career, they're with you.
Yes.
Totally. And I think, again, that's a big difference. But again, I think a lot of groups, this is true even back at the beginning of Microsoft Research. A lot of outside organizations that, they would create, quote, research groups, right? But they didn't believe in what they were doing.
Right.
They didn't understand why they were doing it. They didn't have a philosophy around it. They were just doing stuff, right? And they figured, if I hire a bunch of smart people, they're going to do stuff, right? And that's, it's not wrong. Smart people do stuff, right? But it's not sustainable, especially when corporate budgets get cut or something goes down, right? And it's not like we never had any budget cuts in research when I was here.
Yeah.
But for the most part, I tried to make it so people didn't actually know that happened. One of my management tricks was to not tell anybody what the budget was, so no one could worry about it, but me, right? And I understood how it worked. I understand how all the money worked and how it functioned, But it's funny when you start letting too many people understand or think they understand finances, they start thinking it's like their bank account, okay? And they start worrying about what goes in and what comes out, right? And that's not how corporate budgets really work anyway. They don't work like bank accounts. If you're, some number of $1 million above or below your budget, no one actually cares.
Yeah.
It's immaterial it doesn't show up on any finance thing. It's immaterial. What they care about is, are you accomplishing your mission?
Yeah.
Right? If you spent some extra money doing that, no one's ever going to question you. If you quote save money but don't accomplish your mission, they'll still fire you.
Yeah.
Right?
Yeah, no one cares.
Right, because no one cares. That's exactly right. Money isn't what you think it is, in a large organization, especially now with how many hundreds of billions of dollars. I remember when Microsoft went over $1 billion, okay? Now we're like so far beyond that it starts to become uncountable. I can remember when I was in an elevator with Bill and Steve, and they were talking about, could we ever, get the value of corporation above, I think it was like $600 million. And there was a certain amount of belief that we might not ever be able to do that, because that was just a ton of money, right? And and back then, that was real money. Again, now no, $600 million seems like chump change, but in the old days, you could actually take your family to the grocery store with that.
Yeah, what did we spend last quarter on infrastructure? I think $38 billion outlays.
Yeah.
I think that's the number.
Yeah,
And that's a quarter, and it's going up.
Yeah, it's funny. One of the hardest. I always think one of the hardest jobs in any corporation is treasury, right? Because when you think about managing that much money flowing in and out of your company, you need a lot of PhDs to do that. Yeah. And thankfully, they have a lot of PhDs, but it's a hard problem. Yeah.
So, Rick, you clearly made some very good bets on Microsoft research and challenged this community, or part of this community, at least those who were there when you were around, to tackle some really hard problems that turned out to have a lot of value. What today would you challenge this community to do that would have that kind of value?
I hesitate to try to give super specific advice because I don't know everything everybody's doing. And my guess is some of the things I would suggest people are probably already working on. It's not like I spend my days, walking around talking with researchers anymore like I used to. But I think certainly, thinking about what we can do to leverage, the level of intelligence. I don't just mean LLMs, right? But the level of intelligence that we now are able to bring to bear on a wide variety of problems, whether medical, material science, I think the biggest question in my mind is how do you pick? I mean, there's so many good problems that you can start thinking about dealing with, right? If I were building systems today, and I know some of this work is actually going on, but one of the things I'd be looking at is like, how do I make the systems really automated, right? And I don't mean automated in the sense that they accomplish a goal and they do the thing over and over and over again. How do I make them adapt to changing requirements and self-modify to adapt to those requirements, based on the inputs and outputs that they're seeing, right? I mean, we would talk about this in the old days in systems, but we didn't really have the tools to really do it. Now I think we have the tools to literally have the system be constantly rewriting itself in order to either more efficiently accomplish its task or to adapt to new behaviors, within the system, right? As you put new workloads in, there's suddenly now new behaviors that were not necessarily anticipated by the original developers. And I think we still, to some extent, not completely, but to some extent, I think we still rely on humans for initiative. And I think we need to start letting that go, and think about how do you allow the systems themselves to have initiative. And that might seem scary to some people, but I think that's one of the areas I would be looking at, right? And to some extent, we used to think about this in the old days, but it was the level of adaptation we were talking about was all like pre-programmed in, right? Is the idea that, we can adjust things, but we've already built those algorithms, are already in there somewhere, and now we're just shifting, what's being done. So I think there's an opportunity there, but I think there's lots of other so many other spaces. And I was just talking with David Heckerman last night, and who used to be here in Microsoft, and they've been leveraging AI for designing proteins and things. And he feels that, they're in trials right now working with Fred Hutchinson, but he feels that that they are right there with the cure for cancer, by being able to tailor vaccines specifically for the particular cancer that individuals have. And they're in trials for that. They're not the only ones doing that work. Moderna has been doing it for a while. Some other companies are doing it, but he seemed really confident that it was going to work. And certainly their early results are very promising. Now, as someone who's been through cancer and came out the other side of it, thanks to a lot of research, probably a lot of it was done with my software. I'm right there for more research being able to save people's lives. I think we're well past the time, but I don't know if you're willing to I think there was another question or.
Yeah, Victor, why did?
I do have a question. I don't know if there's a short answer to the question, but I kind of wanted to say a few things before I said the question. I'll just ask you the question now. And that's about, when you left, sorry, thank you. When you left, we have had managers who have had different types of priorities. For example, when you left, I would name the name person. One of the first things that happened to me was to tell them what the ROI was. I had not faced a question like that in the past about what the ROI of the work that we were doing, but that's okay. I mean, the particular manager was very ambitious, wanted to get more money from Amy Hood, and so she had asked him this question that I can give you the money, but what do you get? What do I get out of it? And so he was trying to go around, trying to get people to sort of figure out what that was. And that was fine. We lived at it. But then as we moved on over the many years, that question became very, very big for all the managers, the ROI. And so what that did to everybody, in my opinion, was it created a culture where there was a lot more emphasis now on trying to help the organizations, the product groups and all that. And that is fine too, but it leads to incremental improvements, and it does not lead to the disruptive things that one can do without worrying about that. So my question to you is, what advice would you give to managers around here to deal with creating an environment where, I mean, all this is good because you have to pay the bills, but also create a culture where disruptive work can actually happen, which does not pay off right away, but it takes a while. Yeah.
So I guess the key thing I would say there is that it's never like that question wasn't asked while I was here. It's just you never heard it because it never went past me, right? And I think that's really the way to think about this, which is it's like budgets, right? There's no reason you should be worried about a budget. I mean, first off, you're not probably very good at it. Sorry, I mean, maybe you are, but I'm just generically, most researchers are really terrible at budgets. And so why give people problems that aren't theirs? It was my problem to explain to the corporation the value of what we were doing. That wasn't everybody else's problem. It was my problem to figure out how much money we were spending and how much we were going to spend and how much money we could give back when when the company needed money back and so forth. That was my problem. It wasn't an individual researcher's problem. They weren't in a position to solve those problems on their own, right? And I think it's important in any organization to be very careful not to, ask people to do things that really aren't their business, right? It's not your business, probably, to figure out what ROI is. It's too complicated, right? You're at the wrong level to solve that problem. Someone else can do it at a higher level and do a much better job, right? And I think that's my advice, which is, and this is true for any individual manager, right? I mean, even down inside the organization, it's like, don't ask people to do things that really isn't their problem, right? Make sure, if you can solve something on your own, just do it. Don't delegate. I mean, I didn't delegate problems to other people. My job was to absorb problems on both directions. And I think that's the way to think about it, right? At any level of management, your job should be to remove the impediments that people underneath you have to accomplishing their mission. And if they do great stuff, right, then you're going to be, praise will be heaped on you too, and everybody's going to be happy and whatnot. And if they do crappy stuff, everybody's going to be unhappy, and you're going to have to fire some people, and it's all bad, right? So you need to create an environment where people can be successful, and can not waste their time doing things that they shouldn't be doing, right? And so I think a lot of times, and this is true even in the product organizations, a lot of times you see managers pushing problems down the org, right? When they really shouldn't be. That's not. They should be solving those problems. They should be absorbing whatever it is, and I don't know what the statistics are today. In the old days, new corporate vice presidents didn't last very long, because about half the time, my joke was that the half-life for, this is true in the old, I have no idea what it is now, but I did the statistics at one point back when I was younger. And at one point, it was the case that it was about 18 months was the half-life, for a new corporate vice president. And the reason was a lot of people just can't do that, right? They can't make decisions quickly. They can't absorb things. They can't solve problems for their organization. And they may have been very good at what they did before. But when you're in a position where there's nobody above you who cares anymore, all right, and that's what a corporate vice president is by definition almost, is like there's nobody above you who really cares about you and your group, that's your problem, right? Then you need to be able to do that. And I think that's, I mean, wherever you are in the org and wherever you are in life, you need to be thinking about, how do you absorb problems that needed to be absorbed, and how do you avoid making people around you do things they don't need to do? In my home, I handle all the finances, and it's all set up in such a way, if bad things happen to me, something it could still be done. But the point is, nobody else has to know, right? I understand. I have it all in my head. I know exactly what's going on at any given time, and I think that's just the way you have to think about it. And that's true even for other things. I mean, it doesn't have to be finance. It doesn't have to be ROI. It could be other kinds of issues or problems, HR issues and problems, things like that. Okay, I think we're probably done, right?
Yes.
Thank you so much.